Let's create a custom image for Jenkins. In this image, we will install the plugins and we will install the Docker in the Jenkins container. So I create a directory. I open the directory in Visual Studio Code. Let's create a folder over here. Jenkins custom image. And I can specify Docker file. I already have the extensions for Docker inside my Visual Studio Code, so you will see a logo over here. So let's start writing our Docker file. So from Jenkins, so it's going to the Jenkins in the Docker Hub, and it will download the latest version from there. After that, I'm specifying this optional variable for labels, and I'm specifying the email ID over here. Then I'm specifying switch to the root user, and we will run the same commands, the one we are using in our local laptop to install the Docker. So we are saying run, go to this website and run the script. So this script contains all the information. It will add the repo, it will install the packages for you, and everything. After that, I'm specifying some environment variable for Jenkins. It will run the setup wizard automatically. So once we have the Jenkins image, we have root access, we install the Docker, and we skip the startup wizard. We need to install some plugins on top of that. You can install these plugins later as well from the Jenkins UI, but I'm specifying it over here. So I'm saying run a command. So if I go to internet and just search for Jenkins plugins, you can find any plugin from here. Suppose I want to install this plugin, Maven plugin, as we are using a Spring Boot application in this example. So we need to compile that application using the Maven. So I click it on how to install. It give me this command, so I can just copy paste this command, and I can paste it over here. So in this container, it will run this command, basically Jenkins plugin CI -- plugin and Maven plugin. Similarly, I'm adding some more plugins over here. So the plugins I'm installing Maven Pipeline plugin, credential binding. So I can bind my credentials into the Jenkins, and I can use that credential ID in my pipeline. Docker plugin, Docker workflow plugin, Maven plugin, and the Blue Ocean plugin for just some fancy UI looking. So once we are done with this thing, we can specify the switch to the Jenkins user. It's not recommended to leave this machine as root user, so in the end I'm specifying users Jenkins. So let's save this Docker file. It has 2 Docker images. Right now I don't have any images. I can run Docker build -t, and I can specify custom Jenkins and version. And as the Docker file is in this location, I can specify .land and press enter. Okay, so I created a directory. So let's go to the custom Jenkins custom image and run the same command. So our image is done. So if I do Docker image ls, so you will see ls -a or images -a will show a custom Jenkins image created 7 seconds above, and the size is 1.15 GB because it contains the Docker and contains the plugins as well. So let's try to run a container using this image. So I can do a Docker. First, let me check if anything is running. So there is no container running right now. So I can run a command Docker container. Sorry, Docker run. So Docker run -p port, 8080 port, outside port, and internal port is 50,000. I'm running it's in the background. So using detach mode -v, I'm mounting this file. Basically, I have a Docker installed on my machine. So using this file, the socket is created between Docker, my base machine, and the Docker container. And I'm specifying Jenkins home volume mount, and it's mounted to var/Jenkins home location. So basically, it's like an NFS. So we have so this folder inside the container will mount it on Jenkins home, and Jenkins home has a location. So we will check it after. So let's uh, give the correct version number. So my version is 01 and press enter. So something wrong over here. Let's check our image name again. So our image name is custom Jenkins, custom underscore Jenkins, not hyphen Jenkins. So let's modify that. Custom underscore Jenkins, and the version is 01, and press enter. So container got started. I can clear the screen. I can do docker ts. You will see 12 seconds ago, there's a container started. This is the image it's using, and this is the default name. So I can specify the name as well. So let's clean this. So I can stop the container, docker stop, and the container ID, and I can remove this. Let's do ps-a. There is no container running, so I can specify name, custom Jenkins. Let's do ps-a. Still using some other name. So let's stop one more time, remove, and do it one more time. Docker rm container ID. Let's give the name over here. This time it's taking our name, custom Jenkins. So make sure when you're giving the name, it should be before specifying the image. So let's first execute into this container and check if our Docker commands are running inside that container or not. So I can run a command, docker execute interactive shell and container ID, and I can specify the name of the shell after that and enter. I can log in into the container. Let's run a command, docker help. So Docker commands are running, so means Docker is installed properly and the socket is mounted successfully. I can exit from this container in case if I want to modify something, or if I want to install some packages, I can log into this container using root user. So -u0 and enter. This time I'm logging into the same container as a root user. And while running the container, we specify the mounting point. So we specified create a volume, name as Jenkins home, and it will mount it in the container at this location. So let's check that volume. So let me clear the screen. If I do docker volumes ls, it shows there's a volume mounted, and I can inspect this volume. Docker volume inspect, and the name of the volume. So basically, the mount point on my base machine is at this location under var lib docker volumes Jenkins home underscore data. So basically, whatever the contents inside this folder will automatically, rsync to this location, and this location is on my home directory, host directory. Sorry. So let's go to this directory. Or let's switch to root user for a second. You will see all the plugins, whatever we installed. It comes on this location. If we create any project or any kind of pipeline, everything comes under this location. So this is useful in case if I lose this container, I have the contents of the Jenkins root directory. I can mount this directory again to the container. So in this case, I won't lose my data, even the container is gone. Let's check one more time, Docker containers. So the shell is running, 3 minutes it's up. I can access this on 8080 port. Let's go to the browser, localhost 8080. So it's saying the information is in this location. So I can execute again to the container. I don't need root user this time. I can do a cat content. So this is the password, first time, one-time password. I can copy this password and paste it. Let's install some suggested plugins. So these plugins are installed in the backend. If you want to see the logs, you can check docker logs -f and the name of a container ID or name, both works. So you will see it will installing this pipeline stage view, metric authentications. All these things are doing it over here, stage view and metric authentications. So you can check the logs. So let's create a user. I'm creating a username as Samay. As you see, the blue ocean plugin is there, so means the plugin installed successfully. I can see this fancy UI. I can integrate this to my GitHub or GitLab or any kind of bucket or repository. So let's create a pipeline. So let's create a GitHub repo or a project where we can push our source code. So I'm creating a new project in GitLab. I'm just giving a name Java app, and these are some optional. So I'm creating a private project, creating a README file, and create project. Let's clone this project. So Java app comes over here. So let's paste our source code in this one. So let's go to this directory first and see. So I'm on the main branch right now. If you want, you can create another branch as well. So under this folder, I paste the contents of the Java application, basically a source code. So if you see, we have a pom.xml file where we specify the version number. We have the release number. So we will try to create a jar file using this name. And under the source, we have application.properties as well. And the application.properties, it's needed a database as well to start the application. So for that, this is the application properties where I create a variable for hostname, port, database name, username, and password. Actually, we are keeping the port as 3306, so we can keep it like that. Username, password, and DB name. And let's save this. Or we are going to pass a separate application.properties. So anything in this file doesn't matter basically. We are going to create a separate application.properties, and we will use that application properties to start our build. Let's push this to our repo. So our source code is here. So let's create a pipeline project in Jenkins. Before that, let me define the correct environment variable. So if I go to the manage Jenkins, if I go to the global tool configuration, I can specify the Jenkins. I can give a name, Jenkins Maven. So it will install this one automatically. For Docker, I can do the same, but it's not required. But because we installed the Docker already, other than that, Git, we can install it automatically. I can give a name as well, Jenkins Git. Pretty much that's it, and I can click it on apply and save. Let's go to our dashboard and create a first project. I can give a name, build and push. So it will build the code and it will push it to the Docker Hub. And this is a pipeline type project, and I can specify pipeline and press OK. Can add the description over here. So multiple options over here. You can write your script over here as well, or you can use some source code management, and you can use that as well for your script. So we already created a project over here. So let's create a Jenkins file over here. Then we will modify that file, and it will use that script in the plugin. So I can specify git. It will ask me for the URL. Let's give a URL. It's need credentials. So let's add the credentials. So I paste the username, password. I can define any ID name over here. We can use this ID name later. So I can just give a name GitLab -ID, and description I can give GitLab password. Let's add, and I can use the GitLab password. It will take the information from my main branch and the script file. I don't have a script file right now. Let's create a script file. Jenkins file. I already have the extension installed for Jenkins as well. So let's save everything. And let's start writing our code first. So I'm specifying run it on any agent. Right now I have just one instance running for the Jenkins. Under the tool section, I can specify the Maven. And this one, I can do it Jenkins-Maven because this name we are using inside the environment variable. Under the stages, I have the first stage called build jar. So the steps for that is basically it will echo building the application, then it will run the Maven package, and it will skip the test. So we have some test for this Spring Boot application. It will skip the test. So let's save this one. So let's go to the Jenkins. Before Jenkins, let's execute the inside the Docker container once. Let's go to the var Jenkins home location. So this is the folder which we mounted on our home host location. Under that, you will see right now there is no workspaces, or yeah, there is nothing right now. So let's try to run this build. So it will create a workspace, and under the workspace we will find our source code. So let's click it on build now. Let's see the console output. So first time it will take some time as it's need to download. So there's an error in the script on line 15. So let's modify that. So let's run our pipeline one more time. So I was missing one curly bracket over here. So add it and let's try to run it again. Let's try to run it one more time. So basically it fetch our code and now it start doing the Maven package and skipping the test from here. So it will take some time. It will download all the required dependencies. So in the meanwhile, we can check it inside the container. If I do ls, you'll see there's a workspace is created. Under the workspaces, there's a build and push project. Under that, this is my source code. And under the target directory, it will create a jar file for this project. So in the meanwhile, it's compiling and downloading the dependencies. Let's create an account on Docker Hub. So Docker Hub will give you one private repository, and rest of them is public. So let me delete this one. So let's create a repository. I can give a name. Spring Boot repo. This is a private repository. I can add any information and click it on create. So build code succeeded. So if I go to the container again, if I do ls over here, you will see there's a snapshot is created with the version number, but we have it inside the form.xml. Right now, this is a static number, but we need to create this one as a dynamic variable. So every time when we run this job, it will create a new version with a different number. So our build code succeeded. Let's try to push this build to the Docker repo, the one we created. So let's add some step to the pipeline. So I can edit this file. Let me copy paste it. So it's a pipeline type project. Agent any. I have just one instance of Jenkins is running. Under the tools, I'm specifying the Jenkins environment variable. The first stage we already understand. It's using the Maven command to build this jar file. In the second stage, it will start building the Docker image. So it's using with credential plugin. So if I go to Jenkins plugin, let's see the package name, or plugin name, sorry, credential binding. So this allows credential to be bound as environment variable. to use inside the pipeline. So over here, there's an example as well. It's using with credential, then the username, credential ID. In this example, it's using credential ID Amazon, and the username is username, and it will create a variable for password, and it will use this username and password variable in the below step. So in this, he's just echoing the password and echoing the username as well. So you can copy paste this line from here and paste it inside your pipeline with credential, username, credential ID. So the credential ID is using the Docker Hub. I don't have Docker Hub ID right now, so let's add the Docker Hub ID inside the Jenkins. So let's go to the dashboard, manage Jenkins, credential providers, global security, manage credentials. Yep. Under the Jenkins, let's add a new credential. And username and password. And the username is and the password, and I can give a name as Docker Hub ID, and I can give a description as well, Docker Hub password. And save this. So we have a Docker Hub ID now, and it's using my it's using the information for my Docker Hub username and password. Let's go to the pipeline one more time. So with credentials, using credential ID Docker Hub, and it's using the username and password variable as password. Then I'm running some shell commands over here. Docker build -t. I'm giving a tag Same Grover, or the name of my account, sorry, Grover Same / Java SpringBoot. So let's see our Spring Boot repo. So let's modify this one, Spring Boot repo, and the tag name, you can give any tag name. So it will build the image with the version v1. Then while logging to the Docker Hub, it's using the Docker login command, and the username, it will take it from that environment variable, and the password, it will take it from this environment variable, and it's using this Docker Hub ID. So, and once it gets the information, then it will run the command docker push Same Grover Spring Boot repo version 1. So let's save this. So now we have two steps over here. So what's the first step? It will run the jar. And the second step, it will push the image. So let's go to our project and let's run the pipeline one more time. You can see the same steps in the classic mode as well. In the classic mode, if I go console output, or you can see it over here as well. So there's an error over here, but it's the first step is passed while building the jar. When it's trying to build the image, it's failing. I can check the logs from here. Okay, as I don't have any Docker file over here, so I need to create a Docker file in which I have to specify what is my target location, on which port this application will open, and all those things. So let's go to our Visual Studio. Let's exit from this one or create a new file. Docker file. Let me copy paste it. So from, I'm using the Open JDK image. This is the Alpine image where Java is already installed. I'm exposing the 8083 port on this image, and I'm saying switch to this OPT directory. And on this OPT directory, copy the build we just created. So our version is 2. So copy it from the target location. So once it's built, it will create a build inside the target location. We already saw that. And copy it to the OPT directory with this name. Then I'm specifying copy the application.properties to application.properties. And I don't have application properties right now. So I can create a file name as application.properties. And I can specify my application.properties over here. So this is the default application.properties comes with a build. I just created some variables over here for the host name, for the DB name, for the username and password, and the server port is 8089. So it will start the application on 8089 port inside the container. Then these are information for logs. We can set it to info or debug mode. Let's save this information. So it will copy the application properties to the application.properties, and we are sitting on OPT directory, so it will paste it on this location. And to start the Java application, we need to specify Java. We can pass our own application.properties instead of the default application properties comes in the build. So using our application.properties -jar and our build employees management web app.jar. Let's add this. So create a Docker file and application properties for the Docker build image, and I can push it to the main batch. Before that, I need to do a git pull. Okay, so let's so our Docker file and the application properties are there. Let's try to build this one more time. So again, there is an error. This Docker file cannot be empty. So maybe I forget to save it. Let's check it. Let's check it. The file is empty. Let's save this one. And push it again. So we have the information over here. Let's double check our application properties as well. Yep, all looks good. So it will do a checkout. It will install the tools. It will do a jar build and build image. So this time it won't take much time as we already have the image inside the target location. This time it's trying to push the image. So it will do a tag and then it will push the image. So let's try to log in, and now it's pushing the image. So over here it's create the image. So while creating the image, it will using multiple layers. So it will download the this Alpine image, then it will do the step which we specified. So it will do expose port, it will switch to the working directory, then it will copy the build to the location. So our build code passed. Let's see the Docker push. Docker push successfully. Let's check it to this location. So we have a version 1 successfully pushed to the Docker hub repo. If I click it over here, you can see the same steps. So it's using the Alpine image. It's setting the environment variable. Default environment variable comes with the image, Alpine image, as there's a Java on that. It will expose the port, change the working directory, copy our build. So it's a 37 MB jar file. Then copy the application.properties. It's some KBs. Then it will run the build basically. So let's try to run this build as we have both the images ready. So we have this image ready. It's need a database as well to start the application. So let's try to create a new file for Docker Compose where we specify which application and which database need to use. So Docker compose.yaml, I'm creating a file. Let me copy paste the syntax. So I'm specifying a Docker compose. I'm specifying create a service name as Java Spring Boot. It will use the image Spring Boot repo. It will expose the port 8083 So inside the container and uh, outside the container on the host machine, it's the same port. Restart always, and I'm saying create a volume. Name is Java app volume and mount it to /opt location. So this is the same way it will mount the volume at my host machine. Then I'm specifying some environment variable. If you remember, we created multiple environment variable in the application.properties. So I'm specifying host name. It will use right now. I don't have MySQL instance, and host name it will use in some way, and the password it will use password. DB name it will use the demo. So Spring Boot, let's add a new service for Spring Boot. Or I can go to the Google and find MySQL image from there. MySQL Docker Hub. So we can create the instance using Docker command. I'm looking for Docker compose file, so let's copy this file. So it contains two services, one for the DB and one for the admire. It's like a front-end GUI where I can see the database and all those things. So let's copy paste this. So DB name, we are using MySQL Spring Boot. So let's modify this one. Image, it's using MySQL image. Let's remove these comments as well for now. There's a default variable come with the MySQL. You can check the variables from here. So environment variable, you can specify the root password, database password, or database name. So let's copy this database name as well. And we are saying when run this service or create this container, create a database inside that with the name of demo, and the password, use the password as well. So this is root password. So root password, let's set it to root. We create a username as summary. So let's see if we have environment variable for MySQL user and password. So we have DB name, we have password, we have username, we have the service name. This is the front end of this SQL server. It's running on 8080 port, and as we have the Jenkins running on 8080 port, let's modify this one to 8888. So inside the container it's running on 8084. That is fine because Jenkins container is a different container. This is a different container, but for outside, I'm changing it to 8888. And let's create a volume for this one as well. So it will create a MySQL volume, and whatever the content inside that, it will mount it on this location. Let's specify MySQL volume over here as well. So everything looks good. Let's save our compose file. So Docker compose file is there. I can run a command docker. Before that, let me check docker ps-a. Only Jenkins is running. Docker images. It has our image, and it has the Jenkins image and OpenJDK image, which is used by our Spring Boot image. So let's and Docker volumes as well. So right now I just have one volume that is for Jenkins, but after running this Docker compose file, it will create two more containers with MySQL and three more containers and front end, and it will run my Spring Boot application as well. Let's run Docker compose -f. Docker compose YAML file up hyphen in the background. So there's an error in line 24. Let's run it again. So let's start pulling the MySQL image. So adminer, the image is pulling, it's pulling the MySQL image, and the Java image we already have downloaded, so it's not pulling that one. So let's check Docker ps-a. Now it will create it our Spring Boot image, MySQL image, and the front end image. Let's log into the MySQL. I can run MySQL -user summary -p. Password is password. You can run command show databases. You will see the demo database is already created. And I can log in with the summary username and password, which we specified as environment variable. I can exit from this one. I can check the logs of my application. You will see the application start and up and running. And I can check I can log into this one. So I start this one on 8883 port. So let's go to localhost 8883 port. I can log in as summary user. Password is password. And the database is demo. And the server is I can log in it. When the application got started, it will create some of the tables over here for employees role, username, and user roles. Let's try to access our Java application. So our Java application starts on which port is specified in Java application. So 8083. So something is wrong over here. 8083. Let's see in which port our application is listening. So we can check the Docker file. Inside the Docker file, we specify 8083, but we have an application properties as well. In the application properties, we specify the application should listen on 8089 port. So when the application code start, it will check this information. It will find the server port is 8089. I can log into the application box and check it as well. So sometimes bash is not installed on the container. I can try with the sh. Let's run ps-er. You will see the application is running. If I check next stat, you will see our application is listening on 8089 port. So let's modify this file. So let's modify. So I'm saying inside it's 8089 port, but for outside I can say 8080, or I can specify 8089 port as well. Let's save this. Let's run Docker compose one more time. So this time it's redirecting for 8089 port. So this time if I try on 8083 port, I can see the application. I can create a new register user over here. So right now, if I go to the database, as the database is created again because everything is on a single compose file. So right now, if I log in, there is users. There is no rows right now for the users. Let's try to create a user. So we created a user test 5555. User is created successfully. Let's check it in our database. You can see the user is created successfully. First name, last name, email ID, and the password is in encrypted form. So right now we are creating the Docker compose file locally, and we are showing the password inside our compose file, and we are running this thing on our local machine. But in the next class, we will learn how we can uh, create an EC2 instance. So, and instead of creating this thing locally, it will create it on EC2 instance, and we can start. We can create a Docker compose file there, and it will run it on the EC2 instance. And we will see how we can pass this in username and password as a variable or a secret text. Thank you.